Welcome to ZoomInData. Hello everyone. Thank you for joining this focused session on performance optimization in Azure Functions. We will cover cold starts, premium plan benefits, async patterns, concurrency tuning, caching, profiling, logging impact, durable functions optimization, host, JSON settings, large payloads, and best practices to balance performance and cost. If you are preparing for certification, an interview, or tuning functions at scale, this session will give you clear, ready-to-use knowledge. If you find it helpful, please like, share, and subscribe to ZoomInData for more Azure deep dives. Let us begin. What are key performance concerns in Azure Functions? Cold starts cause high latency on first execution, especially in consumption plan. High concurrency can lead to throttling or resource contention. Slow external dependencies, databases, APIs, dominate overall execution time. Large payloads or memory-intensive operations cause higher costs and slower runs. Excessive logging or verbose diagnostics increase overhead. How do you reduce cold starts? Switch to Premium Plan. It keeps instances warm and eliminates cold starts. Use Always Ready instances in Premium to pre-warm a minimum number of instances. In Consumption Plan, use a timer-triggered function to ping the app periodically. Keep function code lightweight. Avoid heavy initialization in startup. Use run from package deployment to reduce startup file extraction time. Explain Premium Plan for performance. Premium Plan provides pre-warmed instances, no cold starts for most invocations. It offers VNet integration and private endpoints for secure, low-latency access. You can set minimum instances to guarantee availability during spikes. Elastic scale-out happens faster than consumption, handles bursts better. It is more expensive but delivers predictable, low-latency performance. How does dependency injection affect performance? Dependency injection in .NET Functions adds slight startup overhead for container resolution. Singleton services are created once and reused. This improves performance. Transient or scoped services are recreated per invocation. Use carefully for heavy objects. In isolated worker model, DI is more efficient. Prefer it for large apps. What is the impact of async, await patterns? Async, await allows functions to scale better by freeing threads during I/O waits. Proper use reduces thread pool starvation and improves concurrency. Missing await or blocking calls, task, result, cause thread blocking and poor scaling. Always use async versions of I/O operations, HTTP client, Cosmos client, etc. How do you optimize binding usage? Use input-output bindings to avoid manual SDK code. Bindings are optimized by runtime. Prefer declarative bindings over imperative SDK calls for simple scenarios. For large data, use blob input-output bindings. They stream data efficiently. Avoid unnecessary bindings. They add overhead even if not used. Explain batching in triggers. Batching processes multiple items in one function invocation, reduces per message overhead. Enable in host, JSON, max batch size, and batch checkpoint frequency for queue, service bus triggers. Use for high volume queues or event hubs. Improves throughput and lowers cost. Ensure function is idempotent. Batch failures can cause reprocessing. How do you minimize external calls? Cache frequent external data in memory cache, or distributed cache, Redis. Batch multiple calls into one. Use bulk APIs when available. Move expensive calls to startup code or singleton services. Use durable functions to coordinate long-running external workflows. What is the role of singleton in HTTP triggers? Singleton ensures only one instance of the function runs at a time, prevents duplicate processing. Use attribute, singleton, on HTTP-triggered functions for critical operations. It is useful for idempotent endpoints that must not run concurrently. Be careful, it can cause queuing and increased latency during high load. How do you handle memory leaks? Monitor memory usage in Application Insights or Azure Monitor. Avoid static collections that grow indefinitely. Use iDisposable correctly for streams, HTTP client, or database connections. In .NET, use Memory Profiler in Visual Studio or Application Insights Profiler to find leaks. Explain connection pooling. Connection pooling reuses database or HTTP connections instead of creating new ones each time. In .NET, HTTP Client Factory manages pooling automatically. Use it instead of new HTTP client. For SQL, use connection string pooling, enabled by default. Pooling reduces connection overhead and improves performance significantly. How do you profile functions' performance? Enable Application Insights Profiler. It captures CPU flame graphs during execution. Use Performance Blade in Application Insights to sort by duration and find slow requests. Check dependencies for slow external calls. Use Visual Studio Profiler for local debugging or snapshot debugging in production. What is the impact of logging levels on performance? Verbose logging, debug, trace, increases CPU and I/O overhead. Avoid in production. Each log message creates telemetry. High volume can slow execution and raise costs. Use information level in production. Debug only during troubleshooting. Configure in host JSON to suppress noisy categories. How do you optimize durable functions? Use continue as new to reset history in long-running orchestrations. Make activities idempotent to handle replay safely. Offload large data to external storage. Pass references only. Enable history pruning to reduce storage costs and replay time. Explain concurrency tuning. Concurrency controls how many functions run simultaneously per instance. In host JSON, max concurrent calls for non-HTTP, max outstanding requests for HTTP. Higher concurrency improves throughput but can cause resource contention. Tune based on workload. Test with load tools like Azure Load Testing. How do you use caching strategies? Use memory cache for short-lived, per instance data. Use Azure Redis cache for distributed, shared caching across instances. Cache external API responses or database lookups to reduce latency and cost. Set expiration and invalidation logic to keep data fresh. What is the role of run from package? Run from package deploys code as a zip file mounted directly, no file extraction needed. It reduces cold start time by skipping file copy and extraction. It improves reliability, no file locking issues during deployment. Enable by setting website_run_from_package equals 1 in app settings. How do you optimize for isolated worker? Isolated worker model, .NET, has lower overhead and better startup time than in process. Use it for large apps. Supports .NET 6 Plus and custom hosting. Configure host. JSON for concurrency and batching. Use DI for singleton services to reduce per invocation cost. Explain extension bundle performance. Extension bundles package binding extensions, reduce startup time by avoiding NuGet restore. Set extension bundle in host JSON to use a specific version. Bundles are cached, faster cold starts than individual extensions. Use latest bundle version for performance and bug fixes. How do you handle large payloads efficiently? Limit payload size in host JSON, max request body size. Stream large data to blob storage instead of loading into memory. Use blob trigger or input binding for streaming. Reject oversized requests early with 413 payload too large. What is the impact of host JSON settings? Host JSON controls concurrency, batching, logging, and extensions. Wrong settings cause throttling, high latency, or resource exhaustion. Tune max concurrent calls, batch checkpoint frequency, and log levels. Test changes with load. Monitor CPU, memory, and latency. How do you use application insights for perf analysis? Enable application insights. Right pointing arrow go to performance blade. Sort by duration to find slowest requests. Drill into dependencies for slow external calls. Use profiler flame graphs for CPU bottlenecks and snapshot debugger for exceptions. Explain scaling triggers for performance. Consumption plan scales automatically based on trigger events. Premium plan has minimum instances and faster scale out. Use scale controller settings in host JSON for fine-tuning. Monitor scale events in Application Insights or Azure Monitor. How do you optimize cost versus performance? Use premium plan for low latency workloads, eliminates cold starts. Use consumption for bursty, infrequent workloads, pay only for execution. Cache aggressively to reduce external calls and executions. Monitor with Application Insights and Azure Cost Management. Optimize slow functions first. Best practices for performance tuning. Use premium plan for latency-sensitive or high concurrency workloads. Make code async and avoid blocking calls. Cache data and batch operations to reduce external calls. Use run from package for faster startup. Monitor with Application Insights. Profile slow functions regularly. Test with load and chaos. Tune host JSON settings iteratively. Balance cost and performance. Start with consumption and upgrade when needed. Thank you for watching this complete guide to performance optimization in Azure Functions, from cold starts to scaling, caching, and best practices. If this session helped you with certifications, interviews, or tuning functions in production, please like, share, and subscribe to ZoomInData. More Azure deep dives are coming soon. Stay connected and keep learning. Thank you. See you in the next video.